Welcome back. So far, we've explored how you entered the field and how modern factories bring together sensors, controllers, embedded systems, communication networks, and industrial IoT to automate manufacturing. Now, let's talk about something every aspiring engineer is curious about, but rarely hears during college. What is the industry really like once you start working? What are the things that textbooks don't tell you?
That's one of my favorite topics because the transition from college to industry is eye opening. In college, most assignments have one correct answer. You solve a problem, submit it, and move on. In industry, there may be several possible solutions, each with different trade offs. One solution might be the fastest, another might be the cheapest, another might be the safest, another might be the easiest to maintain over the next 10 years. Choosing the best solution isn't just about technical knowledge, it's about understanding the business, the customer, safety requirements, costs, and long term reliability. That's something I didn't fully appreciate when I graduated.
So, engineering is just as much about decision making as it is about technology.
Exactly. One of my mentors used to say, anyone can build a system that works. A great engineer builds a system that keeps working for years. That stayed with me. When you're designing an automation system, you're not thinking about today. You're thinking about what happens after thousands of operating hours, after different operators use it, after new equipment is added, and after production requirements change. Good engineering is about designing for the future, not just for the demo.
That's a perspective many beginners may not have. What else surprised you when you entered the industry?
How much time engineers spend understanding problems before writing a single line of code? In college, we're often eager to start programming immediately. In industry, experienced engineers ask questions first. What is the customer trying to achieve? Why does the current system fail? What are the safety requirements? How will operators use the machine? What happens if power is lost? What happens if a sensor fails? Only after answering these questions do they begin designing the solution. I realize that asking the right questions is often more valuable than rushing to provide answers.
Many learners believe programming is the most important skill in industrial automation. Would you agree?
Programming is definitely important, but it's only one part of the puzzle. Imagine you're building a smart traffic signal. Writing software is essential, but you also need to understand traffic flow, sensors, electrical systems, timing, safety rules, and what happens during a power failure. Industrial automation works exactly the same way. Programming alone isn't enough. You need to understand how machines behave in the real world.
If programming isn't the only critical skill, what skills became surprisingly important?
Communication. Without question, engineers rarely work alone. On a typical project, you might collaborate with mechanical engineers, electrical engineers, quality teams, production managers, maintenance technicians, procurement teams, software developers, and customers. Each group has different priorities. If you can't explain your ideas clearly, misunderstandings happen. Sometimes the biggest delays on a project aren't caused by technology, they're caused by poor communication.
That's interesting because communication isn't usually associated with engineering.
True, but imagine trying to troubleshoot a machine while three different teams each have a different understanding of the problem. Clear communication saves time, it prevents mistakes, it improves teamwork, and it builds trust with customers. Over time, I realized that the engineers who advanced fastest weren't always the smartest. They were often the ones who communicated effectively and worked well with others.
Another thing many people worry about is making mistakes. How does the industry view mistakes?
Mistakes are inevitable. Ignoring them is dangerous. One of the healthiest habits I learned was documenting every mistake. After every project, our team would ask what went well, what didn't, what can we improve next time. That mindset helped us grow much faster than pretending everything was perfect. The goal isn't to avoid every mistake, the goal is to avoid repeating the same mistake.
Let's talk about technology trends. Every year we hear new buzzwords: AI, digital twins, edge AI, smart manufacturing, predictive maintenance. How should beginners think about these?
With curiosity, but also with balance. Every few years, new technologies generate excitement. Some genuinely transform industries, others are simply marketed well. The key is to focus on the fundamentals first. For example, people often ask me whether they should immediately start learning AI for manufacturing. My answer is always the same. First, understand how machines generate data, learn how sensors collect information, understand controllers, learn industrial communication, study embedded systems. Once those fundamentals are strong, learning AI becomes much easier because you'll understand the data it's working with. Skipping the basics is like trying to build the roof before laying the foundation.
That's reassuring because many beginners feel overwhelmed by the number of technologies they see online.
I completely understand that feeling. Technology moves quickly. You don't need to master everything at once. Instead, think of learning as climbing a staircase. The first step might be understanding electronics, then microcontrollers, then embedded programming, then sensors, then communication protocols, then industrial IoT, then system integration. Each concept prepares you for the next. Trying to jump to the top usually leads to frustration. Steady progress always wins.
Let's discuss grades. Many learners believe that high grades alone guarantee a successful career. What has your experience been?
Good grades certainly show dedication and they can help you secure interviews. But interviews open the door. Skills help you stay in the room. Companies want engineers who can think logically, troubleshoot systematically, learn continuously, and adapt to new technologies. I've interviewed candidates with excellent academic records who struggle to explain how a simple sensor works. I've also met candidates with average grades who built impressive personal projects, understood practical engineering, and solved problems confidently. If I had to choose between memorized knowledge and demonstrated skills, I'd choose demonstrated skills every time.
That naturally brings us to projects. How important are they?
They're incredibly valuable. Projects show curiosity, they show initiative, they show that you're willing to learn beyond the classroom. Your first project doesn't have to be complicated. It could be a simple temperature monitoring system, an automatic plant watering system, a smart parking prototype, a conveyor simulation, a basic industrial IoT dashboard. Through projects, you'll discover challenges that textbooks never mention. And that's where real learning begins.
Before we wrap up this segment, if you had to share one truth that every aspiring automation engineer should know, what would it be?
Don't measure your progress by how many technologies you've heard about. Measure it by how well you understand the fundamentals. Technology names will change, platforms will evolve, programming languages will improve, new devices will replace old ones. But engineers who understand systems, think logically, communicate well, and keep learning will always remain valuable. Those qualities never go out of style.
That's a powerful takeaway. Today we've learned that successful automation engineers aren't defined by grades or buzzwords. They're defined by curiosity, problem solving, communication, teamwork, and a deep understanding of engineering fundamentals. In the next part of our conversation, we're moving from lessons to real life experiences. We'll hear stories from the factory floor, projects that nearly failed, unexpected bugs, difficult customers, high pressure decisions, and the engineering lessons that can only be learned through experience. You won't want to miss it.